Alright guys, well, we're getting ready for the Unit 8 exam that's coming up. You'll recall that this is all things radical functions, so we've got quite a bit to cover, but you guys will be just fine. So let's go ahead and get started. On this first question, it is asking us to solve for the inverse of f of x of 2x minus 5 cubed. Okay, so we have f of x equals, in parentheses, 2x minus 5 cubed. You'll recall when we're solving inverses, the first thing we want to do is replace f of x with y. So we'll say y equals 2x minus 5 to the third power. We then want to switch our x and our y for inverses. So we're going to say x equals 2y minus 5 cubed. We want to isolate y, so what we're going to do next is we are going to take the cube root of both sides, because cube root and cubed simplify out. So we'd have the cube root of x equals 2y minus 5. Okay, and then from here we would add 5 to both sides, which would give us the cube root of x plus 5 equals 2y. And then lastly, we want y by itself, so we divide both sides by 2. And it's going to be the whole both sides by 2. So these two simplify out. So to rewrite this, we'd have y equals the cube root of x plus 5, all of that over 2. And then lastly, because it is an inverse, we want to make sure that we do that proper notation. It would be f inverse of x equals the cube root of x plus 5 over 2. And there you go. That's it for that problem there. So now I want you to try these steps on this question here. If you need to go back to the previous problem here in the video, by all means, please go back. If you have any questions, let me know. Send me a message. Let's go ahead and move on. All right, so for this one here, pretty straightforward. It just wants to know what is the fourth root of 256. Okay. In other words, they just want to know fourth root. I'm sorry, it wasn't just a fourth root of 256, it was 81 over 256. And so we could split this up into two parts. We could say the fourth root of 81 over the fourth root of 256 if you're doing this by hand. If you're just going to use Desmos and plug it in, well, you get your answer. But let's go ahead and do this by hand here. You'll recall when we do our fourth roots or anything like that, or even when we're simplifying, we want to come up with our tables. So 2 to the 4th, and then we'll do 3 to the 4th, 4 to the 4th, and we'll stop there. 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. That might be a factor for 256, we'll see. We'll do 3 to the 4th. 3 to the 4th is 3 times 3 is 9, times 3 is 27, times 3 is 81. Oh, okay. So that's important. For 4 to the 4th, 4 times 4 is 16. Okay. And then we're going to go ahead and do 16 times 4. So 16 times 4 is 64, times 4 is 256. Oh, okay, cool. So this pretty much all worked out for us. So what this means is that we are going to use this here and this here. This is essentially the fourth root of 3 to the 4th over the fourth root of 4 to the 4th. The fourth roots and fourth powers would simplify out, same on both sides, and we're just left with 3 over 4. We're donezo with this one here. Okay, again, you could have just used Desmos, plugged it in, but I want to make sure that we understand the concept here as well. So let's go ahead and move on. You have this problem with fifth roots. Take your time. There's no rush. If you get stuck, then please, of all means, use Desmos. If not, go ahead and send me a message. All right, so for here we want to simplify. The issue with this problem is we do not want radicals in the denominator. That is a no-no, right? We don't want radicals in the denominator. So we want to use the conjugate, all right? And the conjugate, if you'll recall, is the same as the denominator. It's all the same expression as the denominator, just a different sign. Okay, so the conjugate for this one would be the square root of 5 plus 1. So what we're going to do here is we're going to multiply the square root of 5 minus 1, and we're going to multiply all of this by the square root of 5 plus 1 over the square root of 5 plus 1. So when we multiply across, 1 times all of this term up here would be just that term, which would be the square root of 5 plus 1. Now in the denominator here, we have essentially like the multiplication of two terms by the multiplication of another set of two terms, right? It's like doing any binomial multiplications, which we had to use our tabular method or box method. I did also discuss with you guys in class that because it is a difference of signs with all the same terms, what we're able to do is we can take that first term and multiply it with the first term, and just those two first terms. The square root of 5 times the square root of 5 we know is 5. And then we can multiply negative 1 times 1, which would be negative 1. If you want to box method this out instead, by all means. But to save time, remember your exam will be timed, so we want to make sure that we're as efficient as possible. And so this would result into the square root of 5 plus 1 over 5 minus 1 is 4. And that's it. You can check your work in Desmos if you put in the original problem, get that decimal approximation, and then check the answer, or check the decimal approximation for our answer here, and we should get the equivalent. Okay? If you have any questions, send me a message on Teams. If not, let's keep going. So you'll do the same thing here. Just remember, it doesn't matter if we have these radicals here on the bottom when we're doing the multiplication. Take the same steps. We just do not want them here in the denominator. So you want to make sure that you multiply by the conjugate. Okay. Your conjugate is the same thing here in the denominator, just a different sign. So it would be the square root of 7 minus the square root of 3. Go ahead and work this through. If you have any questions, let me know. All right, so on this one here, we have a little bit of transformations. It says, given the function below, identify the turning point after the transformations listed below. So the turning point is going to be here where we're turning, okay, where we're changing directions. And this point is at 2, 4. Okay. What happens here is the first part is saying we're doing a horizontal stretch. Horizontal, you recall, is our side to side, right? So we're going to be affecting, it affects our x value by a factor of 3. So what's happening here is we're going to have to go from 2, 4, and we're going to stretch him out horizontally, which means side to side, by 3. So what happens is we're actually going to be doing 3 times our x value, which is 2, which equals 6. So our new point, we're going to be going from 2, 4 all the way out here, okay, to 6, 4, because we stretched him out, right? So this was the stretch. It now says a vertical translation of 2 units down. So we're going to go here. So this affects the y. All right. So we're going to go 2 units down. 1, 2. So we would be somewhere like down here. And if we go 2 units down, well, that doesn't affect our x, but it does affect our y. So we would go down from 4 to 2. Okay. So we've done this one, we've done here, and then it says reflection over the y-axis. So our y-axis is this bar right here. So we're reflecting, so it's like a mirror. So if we're treating this like a mirror, and we're reflecting, if we're 6 units away here, okay, well, we're going to be 6 units away over here, and our mirror point would be all the way over here at -6, 2. And I realize that yellow probably wasn't the best color. So let's do that again, -6, 2. And this was because of the reflection. So if we stretch it out by 3, we went from 2 to 6, because 2 times 3 is 6. We then went down 2 units, so down 2 units, so we went from 4 to 2, and then we reflected, so our final answer would be here at -6, 2. Okay, so this is for transformations. A little bit of a puzzle, if anything. Okay, take your time on the next one. So when you're working through this one, and let me first help you guys with that point there. Our point here is going to be at 1, 1, our starting point here. So you want to stretch this out by 3. Hint, hint, you're multiplying by 3. You're then going to translate a unit down, and then you're going to reflect. Okay, go ahead and try this out. And message me if you have any questions. Let's go ahead and get moving. So for this one here, I'm asking you, what are the transformations of the given function? And this one looks a little different than what we're used to. So let's go ahead and discuss it. So it says f of x equals -2, and in parentheses we have 1/2 x plus 2 cubed. Okay. So what throws us off is typically we didn't used to have like values in here. So I want to factor this guy out. So when I factor him out, what it's going to end up looking like, and let me change colors here, is we're going to have -2 times, I'm going to factor out a 1/2. So 1/2 times x equals 1/2 x, okay. And then 1/2 times what gives me 2? Well, that would be 4. You can check my math. But yeah, 1/2 times 4 is 2 cubed. Oh, okay. So that's making a little bit of sense there. But we still have like crazy things happening here. So how does this work? Well, what's really happening, remember we have this cube, is we can break this down as to -2, 1/2 cubed, because these are factors and they're both being cubed, we can break them down to 2 different terms. And then we have x plus 4 cubed. So this is what we're used to, this x plus 4 cubed. We know we'd have that 4 units to the left business going on, right? But this stuff we can simplify. And that's the real skill here that I want to target. So we'd have -2 times 1/2 cubed. 1/2 times 1/2 would be 1/4, and 1/4 times 1/2 would be 1/8. Times x plus 4 cubed. Lastly, when we simplify this, we would end up getting f of x equals -2 over 8 would give me a -1 over 4. X plus 4 cubed. So now with this guy, we can do and identify our transformations. So what happens here in this red, we know that we're going to have a, because it's negative, we're going to have a reflection. The 1/4 means we're going to have a vertical stretch by 1/4, or it could also be a horizontal compression by 4. So this could also be a horizontal compression by 4, right? One or the other. I know the tests usually do that. And then what happens in the inside, this x plus 4, we would go 4 units left. Because if we set x plus 4 equal to 0, we get that x equals -4. And so we want to go 4 units left. And so this was only, we were only able to do this because we had to simplify. So remember, we want to factor out whatever they give us. So we factor that out. Make sure that that factoring works. You can check it back in, right? 1/2 times x is 1/2 x. 1/2 times 4 is 2. So that worked out. You want to do whatever operations happening to that fraction or whatever number we factor out, and then just simplify everything out, and then get your transformations. So this is our answer here. Let's go ahead and move on to your problem. So on your problem, you're going to want to do the same thing. So let me help with the rewrite first. We have f of x equals -6 times 1/2 x plus 3 to the 3rd power. So we can't do the transformations yet because this 1/2 is messing us up. So we want to factor this out. Look at how I factored it out on the previous problem and just emulate my steps. If you have any questions or concerns, let me know, and I'll be more than happy to answer them. Okay, let's go ahead and move on. All right, guys, so this one here is asking us to simplify an expression. The way we would see this is we could see it as 3x to the 1/2 power, right, times 6x squared to the 1/4. Now what's happening here when we want to simplify, as you'll recall, we did all this with polynomials, and we did all this with radicals as well, but we want to make sure that we distribute these 1/2s to these values. What I mean by that is we really have 3 to the 1 and x to the 1. So what we're going to be doing is we're going to need to multiply. This is how we simplify these out here. We multiply. Remember, when you take one power raised to another, you multiply those exponents. We would have 3 to the 1/2 times x to the 1/2 times, well, 1/4 times 1 would be 6 to the 1/4. And then here we'd have x to the 2/4. Now to kind of simplify these out and what these look like, and the order, I'm going to kind of do a couple of things at once. Let's go ahead and do 3 to the 1/2. Now everything's being multiplied, so I'm going to move this 6 over here. And this would be 6 to the 1/4. Then we'd have x to the 1/2. And that's for this x here. And then x to the 2/4 is the same thing as x to the 1/2. And that's important, okay? These values here, it gets a little tricky. I don't want to get too much into the logistics of how we can combine these. What you could end up doing is, we know that 1/2 to the power of 1/2 is the same thing as the square root of 3 times the 4th root of 6, right? Because the power of 1/4 is 4th root. You can leave these like these. Okay, we could essentially break down that 3 to the 1/2. But we're not going to want to do that. That would give us some decimals and all that good stuff. So we can leave it as such. This is pretty much already simplified. But what I am going to want to do here is if you wanted to, you could put these into decimals and you'd get approximately 2.71 if you just want to see a number. Now over here with these x's, okay, what happens here is we are multiplying x to the 1/2 times x to the 1/2. Now, when we're doing this here, it's like multiplying x times x. And you guys know that x times x equals x squared. And why was that? Well, what you did here is you took these values here and you added them. Well, we're going to do the same thing. We're going to do x to the 1/2 times x to the 1/2. What happens here is when we do this, we would end up getting 1/2 plus 1/2, right? Equals 1, so we get x to the 1. So then we'd end up just getting x. So you could say our answer is approximately 2.71x, or the square root of 3 times the 4th root of 6x. Okay. I guess. So I think the biggest skill is just make sure that you're identifying what's really happening with these x values. But let's go ahead and move on. So here on your student practice, it's a lot of the same skills. Okay, so make sure that you set this up. Distribute that 1/2 to every value within the parentheses. So you're going to distribute the 1/2 to the 2. You're going to do that to the x. You're going to do the 1/4 multiplication to the 4, and then to the x squared. And this is for the exponents. Okay, so make sure that you guys set that up correctly. Go ahead and go back to the previous problem if you have any questions as far as the exponential multiplication and power rules. Okay, let's move on. So here we're simplifying the expression. This one is actually pretty neat. I like this problem. What's happening here is we can actually rewrite this as 4 times x to the 7th y, all of this to the power of 1/6. Because the 6th root is like taking a power to the 1/6 minus 2x times, this would be the 6th root of x, y to the 6th. Okay? So if we do this, I'm sorry, this should be to the 1/6, right? To the 1/6. What we're going to do is we're going to do like we did in the previous problems, is we're going to multiply this to our exponents. We're going to do the same thing here, right? These would be 1s. We'd multiply and multiply. So what ends up happening is we'd have 4 times x to the power of 7 times 1/6 is 7/6. Okay? And then we have y to the 1/6 minus 2 times x, right? These aren't affected because they're not inside the parentheses here. And then times x to the 1/6, and then y to the 1/6. And you're probably looking at these as like, well, you know, I can't do anything else. I can't add or subtract these because I have like these extra x's. And the problem here is, and what I want to make sure that we identify, is what's happening here and here. There's two ways of approaching this. We can simplify this 7/6, right? We can actually break this down into two different factors of x. Or what I also want to get with you guys here is, I'm going to look at this part here. What we're going to see here is if we have x to the power of 1 times x to the 1/6, like we did in the previous problems, we want to add these two terms. Well, just like fractions, I can't just add them. It's not 1 and it would be 2/6. That doesn't work, right? We have to have common denominators. So 1 is essentially the same thing as x to the power of 6/6 times x to the 1/6 equals, well, if I add these together, I get 7 x to the power of 7/6. Oh, right. Now this should start making a little bit more sense. So what happens here is I can actually rewrite this to 4x to the 7 over 6, y to the 1/6, minus 2x to the 7 over 6, y to the 1/6. And so because we have all the same variables, I can add or subtract the coefficients. In this case, it would be subtraction. 4 minus 2 is 2, x to the 7 over 6, y to the 1 over 6. And this would be our answer. Okay? This could be written in radical form, and we could come back to like what's going on here. We could take this to the power, or like do what we need to do, and we could also say this would be 2 x to the 6th root of x, y. And this is another way of writing this out here. Okay? Desmos doesn't really help with this, so make sure that you really kind of dig deep into what I'm doing here. Especially you guys, if you have any issues with these powers, please ask me for any help on the actual review day in class. Okay? Or if you have any questions at home, send me a message on Teams. I'll be more than happy to help you guys out. Let's go ahead and move on. This is your problem. Same skills. I know we now have 8th roots. It's going to be the exact same skills, guys. Follow the steps one at a time. You'll be just fine. Okay, let's go ahead and move on. Okay, so this one here, we were given solve for x of the given function, and we have all this crazy stuff happening, cube roots and everything. Essentially what you should be able to do and understand is that you could drop those 1/3 powers because they're both equivalent to each other as far as the powers are concerned, and solve for x. If you're struggling with that kind of stuff, plug it into Desmos. This is a timed exam that we're getting ready for. I don't want to waste your time. Okay. And so we could just get here that our answer is crossing here at -1. So we would say x equals -1 is our answer. Okay. Like I said, though, we could essentially just drop these cubes because they are the same, and we could just solve for 2x plus 7, okay, minus, and don't forget that minus goes for everything inside the parentheses here, minus x plus 8 equals 0. We could then go 2x plus 7 minus 3x minus 8 equals 0. We can combine like terms. We get 2x minus 3x is negative x equals 7 minus 8 would be -1. Oops. Let me erase a little bit down there. Yep. -1 equals 0. We could add 1 to both sides to isolate x. So we get -x equals 1. But then x equals -1. So this is how we could do it by hand. Again, on these solving ones, if you're short on time, we've only got a few minutes left, plug it into Desmos, move on. You guys already know how to solve. Okay? This is your practice problem. As you can see here, I did not give you the answer on Desmos. You can take the time to plug this into Desmos, or you can drop these cubes, distribute the negative, and solve. Okay, let me know if you have any questions. And for the last problem set that we're doing here, we are doing solving cubic inequalities. And so with these cubic inequalities, it's going to follow a lot of the same rules that we've done in the past. If you're crunched on time, use Desmos. That's what I did here. And I can see here that we're crossing at, that's between -8 and -9. So it would be like x is greater than -8.5. If we were going to say this in interval notations, we would go parentheses -8.5. It would be negative, oops, that was not the eraser, it would be negative 8.5 comma infinity. Okay, and remember we use parentheses because we're not including that negative 8.5. Okay, again, we're not including. If we were going to do this by hand, okay, we would take this negative 6 cube root of 2x plus 9 is less than 12. We would divide both sides by negative 6 to simplify it out. That gets simplified out. We'd have the cube root of 2x plus 9. Now, because we are dividing by a negative value, our sign flips. We'd have 2. To get rid of a cube root, we want to cube both sides. These simplify out. We'd have 2x plus 9 is greater than 2 times 2 is 4 times 2 is 8. We would then subtract 9 from both sides. Okay. Oh, and I'm sorry here. I just realized I made a mistake. 12 divided by 6, okay, is a negative 2. And so when we multiply this out, we would actually get a negative 8. And this makes a huge difference. And we would have seen that right now, but we'd end up getting 2x. These simplify out is greater than negative 17. So if we have 2x greater than negative 17, and then we divide both sides by 2, simplifies out, we get x is greater than negative 17 over 2, which is the same thing as x being greater than negative 8.5. But again, for time's sake, you can use Desmos, and then we still want to follow the same rules here as far as interval notation. We're going from negative 8.5 to infinity. All right, and so this is your problem here. You want to follow the same rules. You can do this by hand by dividing both sides by negative 5. Remember, the sign would change. You're going to cube, do all the things, or use Desmos. Guys, I understand this is a very lengthy review. Please go through its entirety. Go through other problems. This is really going to help you and set you up for your Unit 8 exam. If you have any questions or concerns, send me a message on Teams. If not, have a great day, and we'll see you on test time. Bye, guys.